All right, so question 3 was a little bit different than the others because the curve we are given is expressed in this way. And so it doesn't actually tell us, x equals something or y equals something. It tells us the relationship between x and y, but we kind of have to figure out for ourselves what the x and y values are. Um, so the first thing I did was to solve for x and y, and that's my note here. So if you solve for y, you get two possibilities. Y is 1 plus or minus the square root of 1 minus x squared, and similarly for x, you get two possibilities, namely plus minus the square root of that expression. All right, so because we can express x and y explicitly, it's not really clear which direction. There isn't like a preferred direction in which to chop up this area. So I set it up for both directions. Let's consider first chopping it up. Let's see. So if I chopped it up like so, then I would be going perpendicular to this axis of rotation. And so that would correspond to the washer method. And that integral would be pi times the larger radius square minus the smaller radius square, integrated between the appropriate endpoints. So in our case, the larger radius would correspond to the larger y value. So the larger y value would be 1 plus the square root of 1 minus x squared. That's what I have here. And the smaller radius would correspond to the smaller y value, so 1 minus the square root of 1 minus x squared, which is what I have here. And now we have to figure out the limits for the x variable. And you see that, so maybe just looking at this expression, so it's a circle of radius 1. And so the x values are going to go from minus 1 to plus 1. And that gives me my endpoints. By the way, I guess I should say that it did help me to sort of recognize that this is a standard equation for a circle. So that was something helpful to know ahead of time. All right, so what if we chopped it parallel to the direction of rotation? So let me use another color. So if we chopped it in this direction, then we would be using the shell method, and that integral is, so when you set up that integral, we get 2 pi times the radius multiplied by, so radius multiplied by height. Okay, so if this is my point y, then the radius is simply the distance between this chop and the axis of rotation. So that radius is just simply y. What about the height? Well, the height is going to be, so the height is this length, which is 2 times the x value. 2 times the x value. And so we know that that's going to be, well, it's two times the positive x value, I should say. So it's going to be 2 times the square root of 1 minus y minus 1 the whole square. So that's why I have this expression. So again, so the radius is just the y value, and the the height is twice the x value. All right, so that was pretty involved already, so I'll put off the integral to another video and we'll pause for now.